Good evening, distinguished dignitaries, faculty members, students, and guests. I am Shriyasha Tari, PhD Research Scholar at the Department of Fibers and Textile Processing Technology. It is my pleasure and privilege to welcome you all to Professor M.D. Teli Endowment Oration. To begin this auspicious event, I request the speaker for the day, Padma Shri Professor G.D. Yadav, Honorable Vice Chancellor Professor A.B. Pandit, Professor M.D. Teli, Dean HRD Professor Adivrekar, and Head of Department Professor Ashok Atle to please come forward for the lighting of the ceremonial lamp. I request our Registrar Professor B.F. Jogi to kindly come for the lighting of the ceremonial lamp. Thank you, distinguished guest. Kindly occupy your seats on the dais. I now request our Dean HRD, Professor Adivrekar, to kindly present a floral bouquet to our esteemed speaker, Padma Shri Professor G.D. Yadav. Thank you, sir. I now invite our HOD, Professor Ashok Atle, to share the purpose of this event and initiate the program proceedings.
Namaste, good afternoon, and welcome to this third Professor Mangesh Teli Endowment Oration. And we are fortunate to have Professor Yadav as the speaker for today's event. Another very important and interesting thing is that we have our esteemed gurus on the dais, Professor Teli, Professor Yadav, Professor Pandit, and other esteemed gurus in the audience, Professor Joshi, Professor Lele ma'am, and the industrial gurus from many industries. So for the students like me, आज ही एक पर्वणी है, गुरुंची मांदियाळी जमली आहे इथे. So for the benefit of students, please take benefit of this and please be attentive and listen to what Professor Yadav is going to say. I won't take much time. I will just briefly introduce Professor M.D. Teli for the sake of the students, the youngsters. Professor Teli is associated with this institute for almost over 50 years now, and he is integral part of the textile department. He joined here as BTech student. He was gold medalist in his BSc Tech, then he did his PhD Tech, and despite getting lucrative offers from the industry, he chose to continue with this institute in the noble profession as a teacher and researcher. And during this course of time, over 150 research students have done masters and PhD under him, and numerous research papers, many patents are to his credit. He is also on the editorial board of many magazines. He is also a member of the board of governors of this institute, and there is a long list of achievements and accolades. I will not go into each and every achievement which is to his credit, because we are more keen to hear to the speaker today. So with the permission of our Honorable Vice Chancellor, Professor Pandit sir, we will start this program. Thank you.
Thank you, sir. To know more about Professor M.D. Teli, I would like to call upon some of his past students. So I now invite Dr. Gangadhar Andhorikar, Principal, Sasmira's Institute of Man-Made Textiles, to say a few words about Professor M.D. Teli.
Dignitaries on the dais, a few words is very difficult to talk about Professor Teli. I am really confused. And J.B. Joshi sir is there, Yadav sir is there, so what to talk now? But Adivrekar, my friend, he told me, you have to come now and express yourself. I'll just take 2-3 minutes of yours. So what I would talk about, so many things are there. But I would share with you, Professor Teli for me is a magician. He has just transformed me like anything. I came from Latur. I recall the days 1983. So for the students' benefit, I would tell that what this institute is doing. I came in 1983. That time, sir used to teach us technology of bleaching and finishing. And along with that, he used to tell us, you have to focus on your personality development, communication, rest all things. After that, I joined Sasmira as a lecturer, but sir was there throughout me. He told me, he kept on telling me, Andorikar, you have to do now masters, you have to go for PhD. If you are in academics, you have to do that. Then I tried to take admission, but sir insisted that you have to appear for the GATE examination. You come on merit. So initially in 1986, I had failed that exam. I had no confidence. But the way sir was telling me, I prepared a lot. I got around 98 percentile and I joined MTech under Teli sir. During my tenure at MSc Tech, during MSc Tech, at the final phase of writing the results and discussion, so sir had called me to his house. वहाँ पर जाके 2-3 दिन, madam used to feed us and we used to throughout the day and night. And the way sir used to give dictation of the results and discussion, it is really wonderful. Those were really the magical days. I will never forget that. And after it, during MSc Tech also, it was sir, because of which I stood first. I got that Manoj Praharaj award also. So this is what, and whatever professionally I am today, whatever little I could contribute to the textile education in the capacity of a diploma polytechnic, it's only because of sir. So Atle was telling about Guru, and so I would say that my feelings for sir is Guru Brahma, Guru Vishnu, Guru Devo Maheshwara, Guru Sakshat Parabrahma, Tasmai Shri Guru Enma. These are the Gurus, these are the gods on earth for us. Sir, keep blessing us. Thanks a lot.
Thank you, sir, for sharing your experiences. I now invite Dr. Deepak Valekar, Global President, Vimal Intertrade, to share his views and experiences with Professor M.D. Teli.
Good evening, everyone present here. All my gurus, my friends and fellow scientists and scholars here. It's my honor here to be here with you, and I really feel very happy and privileged to stand before you and express my feelings for Dr. Professor M.D. Teli. For that, let me take you back to 1985 when I joined UDCT first. In initial days, I was really scared about sir. Not me, I was not only a student, but most of my other classmates also had same feeling, initially fear, because sir ka style yo dabang style tha pehle. Initially he is having that kind of actually personality. But later when I started getting more opportunities to interact with sir, I really got to know the strongest human element within him. So to narrate that story, just I'll take one experience of mine when I was doing my project work. You know, for all, we can do lot of actually lab work, but actually converting that into the, articulating that into a very good scientific way, that was very difficult for all of us. So sir used to call us to his residence. For me and my project partner, he invited us to at his residence to discuss and finalize the projects and discussion. So if I recollect correctly, we started results and discussion at 10 o'clock. At a stretch up to 3 o'clock, midnight, we were actually discussing all those results and discussion. So whatever work we did, actually I could able to realize how that can be converted into the articulate, into the scientific way. So 3 o'clock, then sir said, let us take a 10 minutes break. Then he made tea on his own. he took us to kitchen. Those 10-15 minutes were really kind of relaxing for both of us, and we could able to understand more about sir. After the break, we started our research and discussion till 5, I think 5 o'clock, if I remember correctly. There was an emergency. Ma'am was into other room, and then she started getting labor pains. So sir was rushing to take her to hospital, and during that time also he didn't forget that he asked us to go to hostel because our exams were approaching. But during that entire scenario, I saw sir was very controlled and calm, and he managed that situation in a very nicer manner. So that was really experience for me and my partner, that in a pressure condition, really how you can be controlled and calm. So that was really kind of experience for both of us. And in the morning, early morning, sir and ma'am were blessed with the new small baby. You all know Shraddha. Now her daughter is here. And in the morning then we went to hostel. So I will not take much time, but very quickly I'll share my another experience during my masters. Actually, I rejoined UDCT after working 1 year for Sasmira. There was a central government project I was working. That project was for 18 months, and condition was that I cannot actually leave organization before completing the project and submitting that to the government of India. But during that, I got admission to masters. With very hard efforts, I could be able to get the permission from the Sasmira that I can attend the lectures and also do the job. So I used to do that jugglery, attending the lectures and going back to the job. During that, actually, I missed filling the examination form, and that was really shocking for me. Not that I will be losing a year, but shocking was that how I can face sir. So with all that actually courage, I went to his cabin. Initially with that Dabang style, he had 4 and 6s, couple of them. Immediately he took me to the registrar office. We submitted the application, request letter to the university. Not only that, he took me to the university, and then he actually see that my application get accepted. And that's the reason I could be able to attend the MSc Tech exam. Otherwise, I would have lost one year. So that is another learning from me, that how you can really do the multitasking, giving equal justice to all your tasks. Generally, in a hurry, we take multiple tasks, but we generally don't deliver that. But that time, actually, I learned how we can take the multitasking. And in addition to that, how we can put the human element into that. So that's what actually I learned from sir, that not only building the career is important, but at the same time, you also have to have that human element into that. And that is still helping me in my career as of today. So thanks, sir, for all that strong, I can say, fatherly kind of support to me. And not only that, to all UDCT, I would like to thanks for actually nurturing me and giving all those learnings and teachings and all those blessings. So thank you very much.
Thank you, sir, for sharing your memories and learnings. I now invite our Honorable Vice Chancellor, Professor A.B. Pandit, for the welcome address.
Today's orator, Professor G.D. Yadav, the name on which the oration is declared, Professor M.D. Teli, Dr. Professor Ashok Atle, Professor Joshi, Ullas, Vijay, all the veterans of textile department, and all veterans are contemporaries of Professor M.D. Teli. And I am sure if given an opportunity for everybody to speak, the time will get consumed in this sharing of memories itself. Now again, this has become a welcome and annual feature which the entire textile department look forward to. Baichwal lecture and MD Teli, Achwal lecture and MD Teli lecture, and of course Nimkars. So these are 3-4 distinct activities from textile department in addition to the expression which will come, which brings the entire community together. Now in the line of distinguished speakers of this, I think the choice of Professor G.D. Yadav is absolutely apt. Started with Professor M.M. Sharma, then Professor Joshi, now Professor G.D. Yadav. And each one has addressed an issue which was initially global.
Then we talked about the issue was elaborated by Professor Joshi of energy, and now out of Roti Kapda Makan, we are going to talk about Kapda part, where Professor Yadav will discuss how his pet topic of green chemistry and sustainability can be utilized for the growth of textile industry and in general the functional textile. I have seen with a lull of textile graduates or textile students not opting for textile.
With an inclusion of functional textiles, the department has again revived significantly, and that can be reflected through the kind of masters and PhD programs which the textile students are opting for in the outside universities. Many of the textile students are being able to secure admission with full funding in universities like Georgia Tech, Wisconsin, where the chemistry which they learn, the technology which they learn, they have been able to exploit it, especially in the area of materials.
So I'm sure Professor Yadav will elaborate further in this particular area of green chemistry technique and how opportunities for these young students who are sitting here are going to be available for them to explore this topic of textile chemistry, technology and processing. Without taking much time, on behalf of Institute of Chemical Technology and my own personal behalf, I welcome you all to this Professor M.D. Teli Endowment, third endowment lecture. Please enjoy the deliberations and discussions and have a fruitful evening. Thank you.
Thank you, sir. I now call upon Dr. Kedar Kulkarni to kindly introduce the distinguished speaker of today's endowment oration, Padma Shri Professor G.D. Yadav.
Good evening, everyone. It's a really pleasure and happy to introduce today's speaker, Padma Shri Professor G.D. Yadav, sir. He is one of the India's most accomplished and prolific engineering scientists, widely celebrated for his path-breaking contributions to science, technology, innovation and policy. He holds the prestigious Bhatnagar Fellowship, the highest honor of CSIR. He is Emeritus Professor of Eminence at the Institute of Chemical Technology, Mumbai, where he previously served as a Vice Chancellor. Recognized globally, Professor Yadav has received over 150 rare and prestigious awards, including Padma Shri in 2016 for his contribution across diverse fields such as green chemistry and engineering, net zero and sustainability, catalysis, chemical and energy engineering, biotechnology, process safety and nanotechnology. The Engineering Council of India conferred on him the Eminent Engineer Award in 2024, while the Indian Chemical Society honored him with the Rasayan Maharatna Award. The Indian Chemical Council bestowed upon him prestigious K.V. Mariwala Award for Industry Institute Linkages. Recently, Maharashtra Pollution Control Board and Environmental Club of India honored him with the Paryavaran Bhushan Award. He serves as Communications Director of the Federation of Asian Chemical Societies, representing 31 countries, and as a member of Finance Committee of Commonwealth Chemistry, representing all the Commonwealth societies. He is associated with two prestigious US academies, the National Academy of Engineering, where he is one of the only 23 living Indians, and the National Academy of Investors, where he is the only second Indian ever to receive this honor. He was named as among the Asia's top 100 scientists by Asian Scientist magazine and received the Excellence in Catalysis Research Award for the Association of Catalysis Societies of Asia Pacific. Professor Yadav plays a key role in shaping India's scientific and innovation policies, serving on 6 AICTE committees, the National Hydrogen Infrastructure Committee, and several DST committees. He currently chairs 2 national committees on advancing India's hydrogen economy, Niti Aayog's curricular economy committees, among others. His mentorship record is exceptional, encompassing 117 doctoral theses, 158 master's theses, 51 postdoctoral fellows, and numerous summer scholars, with 570 original research papers, 137 patents, and over 21,000 citations. He currently serves as a president of the Indian Chemical Society and the Maharashtra Academy of Sciences and chairs several DST committees. He is vice president-elect of the Indian National Science Academy. Beyond science, Professor Yadav is a poet and author in English and Marathi, having written the University Song of ICT. He deeply engaged in Sanskrit, Vedas, philosophy, reflecting his multifaceted personality. I request Professor Yadav to enlighten the August gathering. Thank you, sir.
I request the dignitaries to kindly occupy your seats in the first row of the auditorium.
Good evening. Satkar Murti, Professor M.D. Teli, Mrs. Teli, Professor J.B. Joshi, the Chancellor, Professor Pandit, Vice Chancellor, Professor Adyurekar, the Dean, Ashok Atle, Professor Ashok Atle, who is the head of the department, and other distinguished dignitaries here, Dr. Vijay Habbo, Dr. Vilas Nimkar, Anil Mehra, Shivram Krishnan, and many others who are there. Of course, Professor Lede, I'm seeing her after a long time. Ladies and gentlemen, dear students, faculty members, and invited guests, I'm indeed very delighted to give this oration in honor of my revered colleague, Professor M.D. Teli, whom I have known for a number of years. I was in chemical engineering and he joined BSc Tech, but we are contemporaries. And you heard very laudatory remarks by students. So I would not go into the details of that, but my lecture will give you something which you will, enjoy. So, Professor Teli, this is in your honor. You deserve more than this. And no man is perfect. He always needs a companion. So, Mrs. Teli is there. She used to come to institute practically every day, if I'm not mistaken. I have seen her. So that is, the great couple. And now, since I chose a topic where I want to connect my experience and also tell you some interesting stories. We live in a world which is highly fashionable. And fashion means what? Fashion is culture, identity, and social status. Now, these days, kids are wearing toned pants, they are rich. Because that is the social status. And there is a continuous evolution, particularly in textile industry, the fashion industry, innovation, technology, and artistic expression. And fashion is always influenced by climate. So now we have to look at climate and choose the dresses which we want. And materials. According to me, textiles is materials. So it is material technology. And whatever innovations are there in materials, they all should be applicable to textiles. And of course, craftsmanship. From time immemorial, since human beings learned how to cover their bodies, textiles has been there in one form or the other. So of course, you know natural textiles, natural fibers, colors, dyes and patterns. You know, the very fact ICT introduced dye-stuff technology here was that reason. Because the textiles were there and dyes were there and there were chemistry. Ours was always called textile chemistry and not textile engineering. More chemistry oriented. So obviously, colors, dyes and patterns, and the trends, subculture and designers, everybody is changing. But what is happening in today's world? We are living in the world where we talk about sustainability of everything. So modern fashions integrate sustainability, circular economy and eco-friendly materials. So I can connect all my research to many of these things. It's not just textiles, polymers. So there is hardly any distinction between polymers and textiles if you use polymers as synthetic materials, so-called polycot or whatever. And this globalization has changed everything across the world. So how it has affected even the courses, I will let you know. And remember, in today's world, people talk about chat GPT, AI, 3D printing, virtual twins, whatnot, and twins. So I'm going to tell you something about this. So let us begin with ancient. The textiles in our scriptures, if you look at the recorded history, because you require proof for everything, in Mohenjo-daro and Harappa and the Indus Valley civilization, cotton, spinning, weaving, all this was practiced. And the artifacts have been left there because textile per se may not be there because it is already degraded. But yes, and you can see that during different eras, all these symbols which we see, they have very interesting facets related to textiles. Look at this. The garments mentioned in epics like Vasas, Uttariya, Nivi or Mekhana, Kausaya, and Valmiki Ramayana mentions, Kaushay, that is silk, Vastrani, etc., etc. And the next important thing is this is a very interesting Sita's trousseau, which is published by the government. And what does it say there? When she was abducted by Ravan, she was wearing silk. It says that. Not only that, it also says Ravan used to like silk. And there are many different things. And so that particular shloka which I have quoted there, it says that, even when the night falls, the joyful mind. What was Sita is described there, that she was wearing yellow, silk. So this is one of the references that we can go back and say where textile industry began in industry. So both Mahabharata, Ramayana and Mahabharata have mentions, and we of course know Draupadi Vastrahana. Right? And so what kind of that thing, what sort of technology were they using? How were they doing this fabric manufacturing? So the artisans and all, do they have something to do? And believe me, they were all eco-friendly. They were all sustainable. They use natural colors. They isolated natural colors. All sorts of things. And we are going back to the same route now. This is what is happening. So cotton, flax, bark, animal fibers, everything is known to you. I don't want to go into the details of that, but this is over the years, you can see this is how people started clothing. This, and when it became society, so clothing took a very central stage. Till that time, it was not. Okay, social values. So if you look at textile and fiber industry, it is the most vital part of global economy. And India also, I will give you some statistics. It's a cornerstone of industrialization because many things were derived. Remember in ICT, look at the history of ICT. Well, we introduced dyestuff and then we also introduced polymers, paints, pigments, and then oils. Our oil technology is just sustainable technology. So they are all linked. And of course, chemical engineering, because all these processes have chemical engineering as a thread. So I will tell you a little later about that also. And India textile industry is the second largest employer after agriculture. So when we talk, and now if you connect agriculture with textiles, you can imagine the impact it will have on this society. About 2% of GDP is produced by this, added by textiles, 7% industrial output, and 11% total global export. You know, our only rival is Bangladesh, although it was once upon a time part of our own country. So textiles has been getting a lot of attention, Indians. So one of the leading producers of cotton, jute, silk, synthetic fibers. Now when the synthetic fibers came, it also brought with us a lot of pollution problems. And this is where the concept of green chemistry comes into picture. So Professor Pandit mentioned about functional textiles. Now everywhere, the best example of multifunctionality is your mobile phone, right? It has a radio, it has everything, whatever, all those gadgets disappeared because the functionality, multifunctionality increased with time. But the mobile phone will not exist there because there are 31 inorganic oxides in that, polycarbonate, gallium arsenide, silicon, okay, and the touch screen, plastic, and the touch screen is indium oxide. So you can imagine, if there is no chemical industry, none of these things will exist. So we have to tell importance of chemical and allied industry to our students. Textile is a part of that. Although while doing statistics, government shows textiles separately. But it is a part of a bigger picture. Anyway, so functional textiles. So now what we want to have a textile, smart textile, design, do research, where the textile will have everything. It will be antiperspirant. It will change the color, use nanotechnologies, change the color. In the morning blue, in the evening red. So you don't have to buy many saris for your wife. Right, because it is multifunctional. Then it can be cleaned very easily, anti-static, whatnot. And the best example is the soldiers' uniforms, multifunctional textiles. So, and this is US dollar 22 billion, and it is supposed to be 40 to 50 billion. And when India becomes Vikasit Bharat, we will be still the most populous country, and we will be having all sorts of gadgetries. This business could go to anywhere between 80 to 100. So we don't know that number. It depends on that type of society. So since I mentioned in the beginning, textiles are materials. Whatever you do with the materials, you will do with textiles. And then take it to the textile application. US dollar 69 billion is natural fibers, animal fibers, okay, and synthetic fibers 87 to 92 billion dollars. This is the, statistics. And you can imagine an Indian market size is very, very large. And so we have to, protect this industry. We have to generate new type of knowledge, because in this world you cannot survive without new type of knowledge. So I will give you something, and overall it is $222 billion. Of course, this slide you might have seen somewhere, but what I'm going to concentrate on the latter part of it, that is natural polymer base and synthetic polymer base, which is you will be compared, right? Whatever was synthetic, it was good. Nylon, for example. But now, can we make these materials by using bio-based materials? And bio-based materials will be everything: chemical technology, catalysis, biotechnology, all sorts of things will be done. And so you can see that particularly acetates, triacetate, cellulose-based, everything is known to you. So that was one of the primary industries. And you go to this. So since we are talking about green chemistry, what is the meaning of green chemistry, and when I am trying to apply to textiles, okay, and that industry? Green chemistry definition is very simple, and I have deliberately highlighted those words. Invention, you invent anything new, design and application of chemical products and processes to reduce or to eliminate the use and generation of hazardous substances. So this is definition of, so process intensification becomes part of this, because you are increasing the rates of reaction. Chemical engineering, it can be described in one sentence. Chemical engineering is nothing but rate process, physical, chemical, biological. You cannot nuclear also. And so it is connected with sustainability. So what we do? We increase the rate, reduce the volume, reduce the processing time. That is what we do in chemical engineering. So any process you take, chemical engineering principles can be applied from atom to atmosphere. So how do we do that here? For example, since we are talking about circular economy and recycling, what do you do with the polymers or the fabric which you throw? Do you know where does it go? After you use your sari or shirt, where does it go? Do you burn and extract energy, or you give it to somebody else? So we extend the life by giving some to somebody else. In United States and many European countries, they have a concept called Salvation Army. Salvation Army, you give your old dress and all, somebody else uses. Or the sibling, the dresses of siblings are given to the neighbor's kids or some. They do the so-called circular economy. So using it again and again and again. So recycling and circular economy. Believe me, in 2047, when we will be 100 years independent nation, we will not have any virgin material. Everything will have to be recycled, reused. Nothing will be virgin. We don't have it. We already consumed all those things. So material sourcing. Eco-friendly dyeing, because dyeing is a part of your. So which type of dye? It should be non-hazardous. It should be eco-friendly. So we go back to the antiquity and Ramayana and Mahabharata, epic Tera Vera, and say that, can we use them? How did they do those? Dyeing. So that is again, so-called eco-friendly dyeing, that concept is coming from ancient times. And then environmentally conscious processes. The idea is to reduce waste. Day by day, we have to reduce waste. You know how much waste we produce today? 1.16 kg per day per person. So you multiply that by the population and imagine how much waste we are generating. And in that, country like India, if you look at the MSW, municipal solid waste, 50% is food waste. 10 to 12% is plastic waste. Then all other things, these numbers you can debate, but yes, that number is huge. So why don't we do something and reduce waste at source? And then innovative biomaterials. So our materials should be all biologically derived, not synthetically derived. So by 2050, we will not have any crude oil. right? So we must have biosource. So our technologies must be oriented towards that. And of course, the sustainable functional finishes. So this is the green merchandising of textiles and apparel is a part of circular economy. So how do we use circular economy? Because everywhere energy is required. We have to use minimum energy, and at the same time, how many times you can use it? How many times you can recycle the material? So there is a limit, virgin material versus recycled material. And you do the combination. So there are rules by government. So if you extend this to so-called sustainable fashion, most important part is reducing the environmental impact of that fashion. Like, how many times you can wash that fabric. Then what is the, detergent which you are used? Does it affect the environment? Does it have phosphorus in that? What is that? All those issues are related. And at the same time, fashion means creativity. Same fabric, somebody can make it a very beautiful garment, apparel out of it. Right? So fashion leads to creativity, and creativity means then also you require different types of fabrics. And in today's context, we want these fabrics to be green. In the sense we have all those things, okay? And very interestingly, because we always talk about sustainable development goals, there are 17 of that. Very first goal is reducing hunger. Second is poverty. Number 9 is innovation, infrastructure, and all those things, industries. Number 17 is so-called collaboration. All these goals, this is listed in that crowded slide, we can apply to textile industry. So textile students must know which goal, like gender equality or water, okay, for instance. All these things are, and reducing carbon footprint. So we can look at all these things from the so-called green chemistry principles, because I embedded that in my title. So what is that? Can we see some new methods by which we can change the dyeing process? Can we reduce, if you reduce the time for dyeing the cloth, you are reduce energy. If you have more absorption of that dye, you are reduce environmental pollution. So you know that in textile industry, first they started about the ZLD, zero liquid discharge. So everything else, the water is recycled. And so that is very interesting thing. And also less hazardous chemical synthesis. Can we have something which we design or do, whether they are textile auxiliaries or something else, why not use the green chemistry principles to have less hazardous synthesis? And of course, safer solvents. One of the biggest problems in industry, particularly in pharma industry, is the use of crazy combination of solvents, which you cannot separate. It has to be recycled. They are VOCs. They go into the atmosphere. Why not think of bio-based solvents? So that is new realization in this industry. Of course, the reactivity must be maintained. You must have proper yields and conversions. But yes, everything is moving away. In pharma industry, crazy solvents, I was a consultant to one company. They use 6 different solvents and they cannot separate it, the close boiling. So they are giving to somebody else, lift it from our factory. Why not develop processes in the first place principle using where you use minimum solvents which can be easily separated and do not have environmental impact. So this idea is now being applied to all textile chemistry. So textile industries, yes. Green nanotextiles. Then I know some of you are working on nanomaterials. So can we use nanotechnology? And the best example is changing color. You put it nanomaterial on your sari, it gives different colors during different time because it is based on intensity of light. So obviously, textile fashion industry can be made totally green by using green chemistry principles. Our courses particularly are green chemistry. Textile chemistry can be labeled as green textile chemistry. Okay, that we can do. So look at this. Aramids, polyamides, carbon, glass, nanofibers, biopolymers. These are all materials, as I said before. Can we synthesize them by green chemistry principle? Of course, yes. There are 12 different principles, and one of the principles says, very first, prevention at source. Prevent at source only. Use minimum number of stages. That will save you save energy. Use, and also atom economy. That is, we are counting now atoms and not the material balance, but atoms. Are all atoms used in the synthesis go into the final product? If they don't go, that means they are useless. Right? Supposing you substitute something by bromine or chlorine or iodine and it doesn't go into the final product, it is of no use. That is how the pollution is created. Then, of course, smart materials, phase change materials. This is what is happening. I mentioned about the soldiers using the same dress is used during winter and also same dress is used during summer. That is the idea. And surface engineering. In fact, surface engineering, you can have treatment of the surface to have different type of things. And in fact, we started one program with atomic energy surface engineering where they said, you come and use our electron beam. You know Professor Jagtap. Yeah, they wanted us to develop textile materials, polymers and all by using electron beam. And electron beam is not radioactive. And so it is, and also nowadays what is happening, you can embed electronics in textiles. And so the days are not far away when we can have all sorts of these functional materials. One is thermoregulative, moisture management, because so it's same dress you use in Mumbai and also same dress you use somewhere where it's dry, in Nagpur for example. Can we do that? So that kind of, thermoregulative, moisture, and then antimicrobial, antiviral, because you don't have to use separate, but you can embed them in the surface. So the functionality which you generate, so you can imagine there may be 5, 6 different functionalities in the same fabric. Earlier it was only one, like wound dressing. The wound dressing may have different functionalities. Then waterproof, like, or the so-called anti-static, odor control, all sorts of things can be done by using these functional textiles. So the functional textile is one. I am very happy to know that you have started a course, master's degree, specialization in functional textile. This has a great future and I will show you a little later what it means. And so since I talked about next generation textiles, what are these next generation textiles? Integrating intelligence, adaptability, sustainability at the material and systems level. And what does it mean? It means that it will sense, it will respond, it will heal, it will communicate and adapt. All those functionalities are brought into the textile material. That means synthesis. That means the synthesis has to be by using the principles of green chemistry and sustainability engineering. Okay, that is what we are supposed to do. So I already mentioned about sense, heal and communicate. Look at this. So you can have embedded sensors. Now we are living in the world which is full of sensors only. Wherever you go, it is sensors only. So smart, adaptive, sustainable. So this is, remember, sustainability is a word which is used by all sorts of industries. All sorts of industries. And Government of India has a committee called Smart Manufacturing Committee. I'm a member of that committee. Every industry is supposed to be smart and sustainable. And so, and of course, and because today is the world of digital, so yes. So we can have wearable medical textiles, energy textiles, for example, converting body movement into electricity. So that is happening because we want to extract energy. While we are walking, we can generate energy. Why not make use of that? Then camouflage fabric, it changes the color and the enemy doesn't recognize you. It's like a chameleon which changes the color. Then there are so-called circular textiles, which is totally, they are made totally from recycled materials. Okay? Or you use it for making something else. Like for example, if they are polymers, we can depolymerize them. So you have upcycling, downcycling, recycling. And that you can have the same thing. For example, PET, polyethylene terephthalate, you can get ethylene glycol and terephthalic acid, purified terephthalic acid. So you're broken back into the original monomers. But in certain cases, you can have something else, like nylons. So yes, and the digital design ecosystem. So what is the role of AI in this? And I will tell you a little later. AI acts as the intelligent backbone of next generation textiles, which enables design, production, optimization is one of the very important things. Because we are talking about materiality, we want to reduce waste, and we also want to have efficient processes. That is the most important part, energy and material efficiency. So AI, because I said that textiles is materials, so some of your courses must have these ideas. Generative design, material discovery, and predictive modeling. All engineering branches can use predictive modeling. Even before it happens, you know that it is going to happen. Now that is the use of AI in all branches of science, engineering, and whatever. You can make use of AI for that. Remember, AI is not going to substitute manufacturing. Manufacturing will be there, but AI will be used as a tool. So I'm talking about this as a tool. So smart factories, quality control, energy and resource optimization, everything can be done by using AI models. Okay? So let us look at AI in smart and functional textiles. Sensor integration in one idea. So the so-called e-textile, heat rate, pressure, motion, everything can be done by using that. Edge computing, so-called on-fabric processors, temperature regulation or moisture regulation, whatever, and adaptive learning. The AI will enable textiles that learn user patterns. You know that, for example, if you use Google or Gmail, by the way in which you do your searches, it remembers and next time it will take you to those sites. AI will do it by looking at patterns. For instance, you like certain type of colors and patterns, it will automatically tell you, you should go for this. This is the fashion, so do for it. And it is going to give that decision to you within minutes or fractions of seconds, depending on what kind of data it has. And also, in everywhere we are these days talking about life cycle. So life cycle of textiles. Okay, so life cycle tracking, sorting, recycling, everything can be done. For example, there is a mixture of all these polymers and metals and materials, and that is dumped in MSW. Can we sort it out easily by using some of these properties of these materials? And in the case of textiles, will be the properties of the fibers or the colors which are embedded on that. So we can have so-called virtual fitting rooms. Okay, these days, I think if I'm not mistaken, we introduced fashion as one of the elective subjects at BSc Tech. Right? It is there, yeah. And then trend forecasting and mass customization. These are some of the areas where AI can be in. Now look at this I already told. Look at the green chemistry principles in microbial finishes. how many things, these are all nature based. All nature based, bioinfant, chitosan, sericin, neem, aloe vera, and all those things can be used now. But now we know much better about them, their properties, toxicological properties, and everything. So we can make use of them in textiles, in so-called finishes. Now, this is one of the papers which was published recently in wet dyeing of wool using binary anthraquinone dyes. And these are derived from walnut bark and lac resin. You can use that. So this is where green chemistry principles have been used in this kind of thing. Or the deep eutectic solvents. This is another area which are safer in comparison with VOCs. They can also be used in textile modification. And look at the bio-based fabrics. I told you that petroleum reserve will not be there by 2050, so we have to go to nature. Very interestingly, I will show you some more slide little later. Hydrogen is going to play a very important role in recycling polymers, materials, synthetic materials. Okay? And at the same time, today we want to reduce the carbon footprint. This year, we have already crossed 40 billion tons of carbon dioxide. 40 billion tons. And what is the so-called net zero? We have to bring it down to 10 billion tons. That means we have to take out carbon dioxide from the atmosphere, or wherever at the source we have to take carbon dioxide. Otherwise the temperature of the globe will go on rising. And so this is unbearable conditions. So in textile industry, you have to design a fabric which will be good during hot summer and also good during winter or climate conditions. But at the same time, you have to ensure that carbon dioxide is not emitted when we are doing it. So this is so-called biofabrics. These are two companies. One is a New York-based company called Evocative, and another is called Alga Life, German company, which is startup company with Israel. They have devised this biofabric made from mycelium, from the roots of mushrooms. So you think that we were during ancient times, our ancestors did it, but this is now being done for leather goods, leather forks and bags. And German company, this Alga Life, they are making dyes which can be then, your fabric can be dyed with that. They said it's creating zero waste. Okay, this is claim, and this company is their a German company. And so regenerated bio-based fibers would be viscose and rayon. Remember, when ICT was started, we started because that national rayon was there. National rayon. They were, and there was no chemical engineering, but our forefathers thought there should be chemical engineering. They had a great vision. That is how these two courses were started in ICT. So now we are talking about, so-called lyocell, bamboo fiber and everything. We are trying to do that. And look at the next generation biomaterials, like polylactic acid. Polylactic acid, now there are two big plants coming in India. One of them is Balram Chimney. Right? It's not only making use of polylactic acid, but also depolymerization. We are studying some of these things in our lab. So, and then you see cellulose, bacterial cellulose, mycelium textile, pineapple leaf, and orange banana lotus fibers. They are giving lots of this, particularly the banana fiber. It is more of a fiber than anything else. So this is very interesting. So look at this bio-base. So we had 1G grain crops, go to ethanol, make it, and from ethanol you're going to go to ethylene and make 11 major chemicals and 19, specialty chemicals. But see, then we have 2G, then 3G, and the carbon dioxide which comes out, that carbon dioxide has to be converted into chemicals, fuels and materials. So carbon dioxide is a very good source of making methanol, dimethyl ether, formic acid, okay, methane, LPG, SAF, all those can be made from carbon dioxide. And we have got some patents in that area. So for example, this vanillic acid, this is a polyester based on that. So this is biodegradable, very easily made. Okay, see how many oxygen compounds are there in that atoms. So divanillin based polyester. And you see there's so many of these PLA, PTT, PCL, PBAT, all these fibers are made using sustainable resources. So that is the next industry. So since it is renewable and biodegradable, it depends on the type of fabric and low emission, low carbon dioxide emissions, all these things are, and also it supports recycling. So I will show you one recycling this. So this is the, okay. So what do we do as far as textile industry is concerned? That is chemical recycling processes. Hydrothermal, hydrolysis, ammonolysis, pyrolysis, gasification, glycolysis, methanolysis, name it. So you do two types. So cotton, nylon, PET fiber, all sorts of things can be certainly converted into value-added products. Some of these products may be fuel, may be chemicals or other products. For example, if you do pyrolysis, you will get biochar, which is good as a fertilizer. You will get bio-oil, which contains a lot of oxygenated compounds. Use hydrogen, make it hydrocarbon from that. There will be also gases coming out of it. So pyrolysis of agricultural biomass, where you can increase the farmer's income, is a good idea rather than burning it. And see how many things we can do. We have done some of these things in my lab. So this is what it is. Chemolysis, pyrolysis and gasification. So waste plastic, including the waste textile materials. Now look at this. This we patented and published also. That is non-biodegradable composite recyclable into monomers. So we have developed a new polyester, okay? And this work, we did it with Michigan State University. And so you can see how many things are done in this. Next is, this is the hydrolytic depolymerization of PET into terphthalic acid. So this is a phase transfer catalyzed reaction. We have patented it and also published. So it is a very interesting theory where we can recover this material. So, in other words, what it means, we have to follow 5 different R's. Typically people talk of 3 R's. That is recycle, reuse, but I am talking about 5. First is refuse. If you refuse, you don't generate carbon dioxide. For example, this PET bottle is there, I refuse to drink it, that means I am not generating carbon dioxide. Yeah, but first is refuse. Then is repurpose. Same thing we can use for something else, right? Repurpose. Then reduce. Reducing at source is the best thing. So can we have, processes where we reduce byproduct formation or material and reuse? And last but not the least is recycle engineering. Tomorrow's chemical engineering will be all recycle engineering. Everything has to be recycled. So what it means is this. We have to incentivize people to recycle. So what is our problem? Why there is so much of pollution? And our government wants to ban plastic, single-use plastic, SUP. Stupid idea. Ban will never solve any problem. Wherever there is a ban, in that state, maximum liquor is sold. You are laughing, but that's a fact. You are laughing, but that's a fact. Why? That means people find out some other means by which they can do it. Now also plastic is banned. You go to market, Matunga market, the buyer will give you more bags. Take it. And then so what is the meaning? The meaning is that we have to incentivize. So incentivize, we want to promote digital economy, right? So have barcode and every plastic bag, 20 rupees. Return it and take your 20 rupees back. So we can have a policy where irrespective of shape, size, weight, thickness, you will get 20. Even the straw will be 20 rupees. The PET bottle will be 20 rupees. Right? Then you take it because you are segregating at source. The 80% of the cost is lost on segregation of plastic material into variety of things. So that is one way of doing it. Why we are not collecting it? Because it is free. Nothing free is appreciated in the world. Nothing free. So if you give plastic free, throw it. But if there was deposit of 20 rupees, you will collect neighbor's bottle also and go and give it. And our best example is marriages, parties, correct? Because the food is free, we take bigger plate. But supposing they had done a trick and said that, sir or madam, you want to eat this food, this dish looks nice, chef has put a lot of effort in that, but put 100 rupee note in this bowl. I can assure you, your wife will not allow you to touch it. Because you never eat at home. Just because it is free, you are touching it. And then wasting it. So when I said 50% food waste, that is the reason. So we must be made responsible, whether it is fabric or anything else, recyclability. And so recyclability, I said chemical engineering will have better days. Of course, students may not believe that, but that's the fact. Okay. So this is where government policy and practical incentive. Somebody says 50 micron bag allowed. Do you go with a measuring gauge and measure 50 micron? Supposing it is 49.55, arguments say. So this is not practical. Any incentive must be practical. Any policy must be practical. So this is where this 5R is coming to. So this is where, I call this new trinity, solar, wind and hydrogen, and I call hydrogen as the savior, because I will show you one more slide where how it can be used in your textile industry also. So hydrogen is the prime Dev. So hydrogenolysis of mixed plastic, rather than segregating that plastic, mixed plastic can be hydrogenolysis. So you break it into make hydrocarbons, and this is all technologies are known. For example, hydrocracking, hydro-denitrogenation, hydro-desulfurization, hydro-dechlorination. These technologies are known. When you generate H2S, HCl, ammonia, this is all known. But you get mixture of hydrocarbons, which can be certainly used. But for that, we must have a policy. And so, what is this policies? So, this is one of the papers which I wrote, that hydrogen can be nicely used to break all these mixtures. Whether it is nylon or polyurethane or polystyrene or whatever, PP and PE, everywhere hydrogen can be used to break that molecule. And so the waste plastic problem, including any fibers, they can be handled by this. So now what are the challenges? In the case of biomaterials, they are more expensive because of the technology. Right now, we require, there are two differences. One in the benzene, toluene, xylene, and another is this all biomass. Benzene, toluene, xylene, BTX, refinery, we go on functionalizing it. Right? It is easy. But there we have to defunctionalize it. And therefore, it costs more. And there are multiple chiral centers and whatnot. And of course, there is this problem of competition for land for food and crops. Right? We are talking about renewable energy required for this. Hydrogen, green hydrogen also requires renewable energy. So what is that? And then we have, bio-based dyes, enzymes, and green processes, and we can integrate AI, biotechnology, and digital textiles. So this is it. So these are These are some of the research papers which appeared recently. Green carbon dots from agricultural waste, okay? And so now I will come to the final part of the education. Decline enrollment in chemical related courses. So I have a solution, okay? So why? This is across the globe. I wrote an article on this, across the globe, including USA, etc. Okay? Chemical engineering, chemistry related sciences has been steadily declining. You want to know something this year? Out of the top 100 advanced JEE students, 71 went to IIT Bombay and all of them went to computer science and engineering. All of them. So what IIT Madras did, they said, parents, you can come to our IIT, see at least, we will give you airfare and hotel, come. They did it. So I had a meeting with one of the IIT directors, second tier director. He said, sir, how come you are getting chemical engineering students in ICT? We are finding it very difficult. so I said, he said, not only that, top 500 students from JEE do not come to our IIT. So I said, give them free education, they will come. Right? You have to give some incentive. What is the incentive? If the top IITs are also giving like that, that means, does it mean that all these courses are useless? Answer is no. But we have to do something to recruit best of the students, get the best distinguished alumni, let them address the students. So for example, I wrote this. We started with textile chemistry, the mother of all industries, right? We started with that. 4th August 1934. Textile chemistry was called branch 1 and chemical engineering was branch 2. Okay? We started with that because textile graduates got good jobs. Chemical engineering. And more number of students joined for textiles. There were 20 admissions. So not half up, 10, but more joined to textile because they say there is a job. That is history. Now look over the years. In 1952 we made chemical engineering as after inter-science 12th. All other courses remain the same. In 1943 this building was constructed. We came here from Institute of Science and all these courses were started. PPV, for example, polymers, pigments, dyes, all paints, everything, oils, everything was started that time. Then again we changed in 1998. We made BTech after 12th because we found the students were not coming. Similar situation has come, right? But we made a mistake. We lost one batch. We discontinued BSc Tech after BSc. So one batch is not there. You will be seeing that. There is no one batch because that somehow the administrator did not think that we are losing students. One batch was killed by ICT during that time. Sorry to say this. Now it is history. Because we went to 12th and we said BSc students are not allowed. That is what happened. So now, yes. So why you can see that? Why it is happening? Because more of peer pressure, glamour of AI, ML, etc. So how do you attract students to play your textiles? Right? How do you attract students? So I have a solution. So we have to have major and minor degrees. We must have major and minor degrees. So students can they can have a synthesized degree, personal degree also, like medicine, right? So take one major, take another minor. Now since this is a jamana of AI, ML, etc., give them in that, but it is applied to your discipline. Okay? And so we must have patience for that. So AI will what? It will, transform textile design from intuition-driven to data-driven science. It will enable zero waste, zero defect manufacturing. It will also enable us to have human-machine synergy. Okay? So fabrics act as intelligent surface interfaces between body and the environment. So they sense, think, adapt, and sustain. That is what is going to happen tomorrow's textile industry. So another reason why perception and awareness is society thinks chemistry means, oh, bad fellows, they don't do anything, or it's not a glamorous science. I say this jokingly, but I mean it. Supposing there is a Swayamvar like Mahabharata and Ramayana, and the girl is waiting with the garland, and 100 boys are there in the queue, she will never put a garland around a graduate of ICT. Because she thinks it's a dirty job, no future, but somebody who is going by, I am IT guy, okay, she will go and garland him. That is image, right? We have to change the image. So we have to make our courses glamorous. Secondly, employment and economic factors, because people, if they are getting a lot of money, overnight they want to become rich, correct? So can we do that? So this is one. Thirdly, theory versus practice divide. That means they must have practice. That is the reason I started this trimester system in Bhubaneswar and Jalna, every alternate term, because that was the reason. I had anticipated that time. Now everybody is talking about it. But that's a fact, much before this NEP 2020. And the curriculum renewal must be continuous. It cannot be after 5 years, in 10 years we revise the curriculum. And you must have a lot of choices, correct? A lot of credit courses. And weak interdisciplinarity. This is one of the problems. We are not linking our courses with some other course. See, chemical engineering always has civil engineering, mechanical engineering, electrical engineering, because it started that way in England. It started like that. In America, it started with industrial chemistry. So we can see that how this can be done, particularly and limited project-based learning. We should be giving more projects, right? We should be doing that. And lack of public appreciation. So look at this. Society benefits from chemistry, but they don't appreciate it. So we have to have, messengers, okay? Then the environmental stigma, you are polluting. That is what is every time they say. That has to be. And this is a policy. It's a government policy, but institutional policy also. Textile is a very glamorous discipline. So this requires multi-pronged strategy. Okay, trimester system I mentioned. And so what do? Integrate emerging areas, major and minor degrees. Make it as experiential. And I am doing it in LIT Nagpur. I am telling you that. I am doing it because I am the chairman of the board. I am doing it there. And highlight societal impact. You have to do that. Otherwise, these courses, how will people know that these courses are very fundamental, critical for survival? Show me any object, man-made object where chemicals are not used. Show me one. I will give you 100 crore. I don't have any, but I will give you. Because you cannot find any man-made object without the use of chemicals. Not even one. So that message has to go. Then another is joint research and internship. That is required. Adopt real industrial data and show career versatility. That is what is required so that the message goes to the students. They will come and join the program. Not you don't have to do anything else. Okay? Then create exciting career pathways, deep tech startup, incubators, bridge programs, including entrepreneurship. Some of these things are being done in ICT, but this can be taken on a bigger scale and including internship across the world, many different labs and universities abroad. And this is very important. You have to communicate chemistry's role in society. And you have to leverage social media because today's world is social media. So why not use it? And have science ambassador programs. So like encourage universities and societies to showcase success stories and innovations. Okay? And this is how we can harness digital and AI tools in textile education. You can do it. You can do it. I won't go into the details of that, but yes, it is all possible. AI-driven, design, virtual and AR labs, digital twins. This has become a, great thing for all manufacturing, IoT tools, 3D printing. All these things can be brought into textile education so that students are attracted. Okay, and we can also enhance teaching, learning, and research. Faculty members can learn these new tricks. You can have sustainability dashboards, live industry feeds, and this you can get really from industry, because for that you have to call a lot of industry people. And so outcomes and future direction, creation of a digitally skilled textile engineers and designs, strengthen industry academia partnership, and acceleration of innovation in smart textiles, functional fabrics, and bio-based materials. So then we can talk about this buzzword of green economy, right? Green economy. So yes, we can have bioeconomy, bio-based economy, carbon dioxide as a feedstock, and net negative and plastic and whatnot. And ultimately, this is what I got one Bhagavad Gita. That is, Annada bhavanti bhutani parajana sambhavas yajnat bhavati paranjanyo yajna karma sambodhva. All beings depend on food, sustainability. Food depends on rain. Rain depends on righteous, selfless action, and such action arises when humans perform their duties responsibly. So in today's sustainability world, we have to perform our duties, and last but not this, this, okay? This so-called, Vasudhaiva Kutumbakam. And so, thank you very much, and I'll be more than happy if there is any question.
In interest of time, we can take the questions at the time of high tea. Thank you, Professor Teli Yadav, for enlightening our minds on how green chemistry principles can be incorporated for transforming next generation textiles. I now request Professor M.D. Teli and our Honorable Vice Chancellor, Professor A.B. Pandit, to kindly present the memento to our honored speaker, Padma Shri Professor G.D. Yadav. I also request Professor M.D. Teli to share his reflections with the audience.
I will not take much of your time. Good evening, everybody. Professor J.B. Joshi, the Chancellor of this university, Professor Pandit, the Vice Chancellor, and our today's speaker, Professor G.D. Yadav, for whom we always call Yogesh, and really, as in his biodata, there are many firsts. And this time, you have played the hat-trick stroke. All the three Padma awardees, they have given this first three lectures, and he is the third one playing that hat-trick stroke. So I really am indeed grateful to you for playing that. And as far as his lecture is concerned, again taking the subject of textile, coming from again textile, the chemical engineering, you really echoed, and that too you mentioned also in your lecture, echoed the vision with which the Mill Owners Association had, created this institute, and the first two disciplines, the textile chemistry, to be supported by the chemical engineering department, this twin with which the UDCT was born in the year 1933-34. That's it. So you again reminded and in fact gave the echo to that vision. Thank you so much for sparing your time to deliver this lecture. My thanks also, personal thanks, there is vote of thanks formally, but then my personal thanks to even Professor Pandit and you dear friends, those who have come from the industry. Today is a day where simultaneously there are 3 or 4 functions in the country related to textiles are happening. There is textile happening, chromatics was happening, color, trend is there in Kanpur, and All India Textile Conference is, being conducted there in Coimbatore. So many of our friends from textile industry, they are there, they are attending. But still, you came, and those who came here from the industry, I know individually you are big shots. You are humble because when we meet you, you always bow down and say that, sir, thank you. But we understand the kind of position which you enjoy in your industry. And actually for a teacher, when we see our so-called past students, but now they are the bosses, and holding such a responsible position, we feel proud. And many of you, when, the Wallekar and Professor Andhorikar mentioned about me, this is also equally important. Being a student of Institute of Chemical Technology, your technological excellence has to be there. And if you are technologically excellent and leading the technological world in this country, it's nothing new and nothing special. That's what ICT meant for, UDCT meant for. But beyond that, what is my dream, if you ask me? I want my ICTians, along with this, Professor Joshi, and you are at the helm of affairs, that my ICTians, in addition to these lessons of, following the technological excellence, the ethical commitment has to be a special, especially stressed. Because many of you, those who are big shot, they have individually, confided in me and say that, sir, we understand you always put that element of continue to have the quest for excellence. But more than that, we appreciate those human values. These are your words, your feedback. And you said that when we also help others, because that's what again my message to them was, that don't help me if at all I have been of some use in your life. Important aspect in you should be that you try to help the others, those who cross your path. I'm so grateful and so happy to know that many of you give that testimony that helped you. Because serving the others only will give you the true happiness. And that is for us, as all these gurus, a real Guru Dakshina from you all. So thank you very much for making this. And my special thanks to Professor Adivrekar, Professor Ashok, and the whole, the faculty of the textile department and their students to have taken so much of trouble to organize this event. Thank you so much.
Thank you, sir. To formally express our gratitude, I now invite Dr. Maiti to deliver the vote of thanks.
Respected dignitaries and eminent personalities present in the auditorium, my colleagues, students and friends, I thank you all for joining us in this auspicious evening for Professor M.D. Teli Endowment 3rd Oration 2025. First, I sincerely thank our former head of the department and former Dean HR, Professor Teli, under whose honor this endowment was started, and this year we are organizing the 3rd endowment. Wish you, sir, a very healthy and long life ahead. We are also thankful to Professor Teli's family members, especially our beloved Teli Madam and his daughter Shraddha. Unfortunately, she is not here today. Aradha, thank you for coming and for their continuous support and active participation in organizing this program. We are very happy to have them with us at this August gathering. The program would not have been initiated without their active cooperation and enthusiasm. I take this opportunity to thank the speaker of today's endowment oration, our former Vice Chancellor and Emeritus Professor Padma Shri, Professor G.D. Yadav, delivering an excellent lecture on the topic Transforming the Next Generation Textiles and Fibers Industry through Green Chemistry and Sustainable Engineering. In his talk today, he has rightly pointed out the growing concerns on the harmful impact of synthetic and conventional engineering routes on the environment. He clearly and lucidly explained the relevance of greener and sustainable approaches in developing functional textiles and utilizing renewable sources with a focus on 5 Rs and circular economy. He has also talked about the opportunities and scope of next generation textiles in today's competitive era. Thank you, sir, for your expert and fabulous talk on this theme. I am grateful to our Honorable Vice Chancellor, Professor A.B. Pandit, for his gracious presence among us. I would also like to thank our Registrar, Professor B.F. Jogi, for his presence during the inauguration program, and his invaluable support is always there for conducting any event at ICT. I take this opportunity to thank Professor A.R. Atle, the head of the Department of Fibers and Textile Processing Technology, for his enthusiasm, tireless effort, and encouragement to his colleagues to make any program successful. Needless to mention, I sincerely thank our Dean HR, Professor R.V. Adiberkar, Dr. N.M. Prasad, founder and director of Chemistar Intermediates Private Limited, and the pass-out doctoral students of Professor M.D. Teli, sincerely and dedicatedly taking the initiative to create this endowment and starting the series of annual lectures under his honor. The result of such tireless endeavors has led us today to successfully come to the third oration. Last but not the least, I honestly thank the audience for your positive and enthusiastic presence throughout the program. Without your presence, no event can be successful. Before I end, I'd like to announce on the behalf of our department that we are going to organize the 10th Dr. M.P. Nimkar Endowment Oration on 19th of December. It's on Friday. And the speaker of that event will be Sri Harish Chatterjee, the Director General of WRA. So we expect all of you again to meet you on that day. Thank you and stay safe and blessed.
Thank you, sir. This year, 2025, marks 150 years of our national song, and the nation is celebrating this milestone with pride. I request the audience to kindly rise to pay a heartfelt tribute to the timeless national song, Vande Mataram. Vande Mataram, Vande Mataram, Sujala, Sufala, Malayaj Sheetala, Sasya Shyamala Mataram, Vande Mataram, Shubhra Jyosna Pulakitaya Sumita Drumadala Shobhini Suhasini Sumadhura Bhashini Sukhadam Varadam Mataram Vande Mataram Vande Mataram. I request all dignitaries and guests to kindly join us on stage for a group photograph. After the photograph, you are cordially invited for high tea, arranged on the first floor above the marble hall. Students are requested to wait back until the guests proceed for the high tea.